So final demo for today is the distance calculation, and our file is going to be in the distances HTML in Lamad Earth. And I modified our previous example a little bit. I defined coordinates for Dubai, and I just added another dot at Dubai to get an idea of where the cities are. And it looks correct, so it strengthens that our previous calculations were good, and it's not just a fluke that ThreeJs worked. So coordinates for Dubai are here, and in addition to ThreeJs we added Dubai, and I separated these. Previously we had everything in one line here, and the line was becoming quite long. So the problem with two long lines is that, well, they are being split into multiple lines, or sometimes, depending if your word wrap is on or not, it may go out of the screen, and then you have to use the horizontal scroll bar for that kind of situation, and it just becomes more difficult to do programming. So in general, you want your lines to be as short as possible when writing good code. And since we have this color as a parameter, let's make ThreeJs green, because it's more green than Dubai. Okay, that's better. And now we can write functions for the distances. So you already knew the formula for the Euclidean distance. And I'm going to have 2 points here, P1 and P2. And I just return the value here because it's a very simple function. Return math sqrt for square root. And here we need to have the P1x minus P2x. Multiply this by itself. You can also use this pal function in the math library, but I'm not gonna do that. And I copied the code for replacing the value of x with y and with z. So this is now calculating the Euclidean distance. And next function is going to be for the Haversine distance. If you notice some error or problem, let me know. Now, the Haversine distance is usually given to points that have degree values. So, yes?
Can you remind me what is the z-axis in the Euclidean distance? Z1?
The z-axis.
Yes. Is it the radius of the Earth or not?
Okay, let's go back to our draw Earth function. Put it back transparent. This blue one is the z-axis.
I thought that there will be a coordinate that will be the same with the 2 dots, and we don't have to put it because it will result in 0 in the Euclidean distance formula.
So if we are going to rotate this so that this axis disappears, you see that they are offset also in the z-axis.
Yeah.
So they are offset in the z direction, in the y direction, and also in the x direction.
Okay.
So there are differences everywhere. There's no zero
Yeah.
involved. And even if there is,
Yeah, we should put it anyway.
the other values are positive.
Yeah.
Okay. Now, going back to our Haversine. So Euclidean function works with x, y, z values,
Yeah.
right? But Haversine function actually works with degree values. It will work with latitude and longitude. So I'm going to rename these attributes as WJS1 and WJS2, and to reuse our formula that we previously written on the board, I need to use the Euclidean function on these locations first. So our Haversine used the Euclidean formula.
Yeah.
So for that I'm going to define P1 is equal to WJS to XYZ. Oh,
Should we not add those 3 times instead of placing commas?
correct. Thank you. Yeah. This saves a lot of debugging time.
Yeah.
So we have the points converted. I'm going to call the Euclidean, let's say E is equal to Euclidean of P1 and P2. So I have now the value for E. And now I can return the Haversine, which is going to be return 2 times the radius. Note that I can put the radius as a parameter here for the Haversine. So it's possible. But usually it's a fixed value. And I'm going to consider it like that, but nobody is stopping you from doing that and calculating distances between satellite orbits or something away from the surface of the Earth. So 2 times the radius multiplied by math a sine function of E divided by 2 times the radius. So before we had E divided by 2 on the top, but it's simplified, simplifying it this way. Okay, and now that we have these 4 functions here, we could call them to see what are the distances between these 2 cities. I'm just going to use the console to log these distances for now. So let's say console log Euclidean of XYZ to Uusniemi. So I have now this variable there. And XYZ Dubai. So this is going to be the Euclidean, and let's make sure that we know it's going to be the Euclidean. I concatenated this string in the beginning. And Haversine, this one works with the WJS version of the coordinates. So I send it the original latitude and longitude values. Yes. Okay, so let's see how this will work. And the name here should be Haversine. I'm going to open this console, refresh the page, and I have some value for Euclidean and some error for the Haversine. So we have to figure out what is happening there. I'm going to also raise back the opacity for the Earth. I remove the transparency from here because it's easier to see the two locations. So we have some value for the Euclidean, and it might be correct. We need to check it out later, but for the Haversine it's not working. So let's look back at the Haversine function. So what do we have here? We have P1, P2, E, the Euclidean, and then some function here. Okay, I will teach you how to debug using this browser. So I'm going to open the sources, and I'm going to look here for our Haversine function. It's possible to, yeah, so this is some other JavaScript file from this fake GPS location that I presented last time. To find the function anywhere in the code, you can use this search box here on the bottom. Ctrl-Shift-F in Google Chrome opens it, and I'm going to write there Haversine, and it's going to find all references of the Haversine name in the source code, and this one is the function definition. So I'm going to open it here, and I'm going to place a breakpoint just when the function starts. I'm refreshing now this page, and this says here paused in debugger. So I'm in this line here, and I have a possibility to inspect each of these values. So I have WJS1, 62, 28, looks good. WJS2 also looks pretty good. And now P1 is undefined. I'm going to use this button here to move to the next line. So P1 doesn't work for some reason, even though it used to work before. I might have done some mistake when moving to the new page. Oh no,
you have to put Haversine after the...
actually no.
Pass the radius.
Yes,
Okay.
I'm missing the radius here as a parameter. I remove now the breakpoint because I'm confident it's going to work in the next refresh of the page. And now this second value is a little different. It looks a little bigger, right? Which is expected because the straight line in Euclidean should be smaller. I'm going to open Google Maps, and I'm going to say, well, Tuusniemi is here. I think there is this measure distance tool, and Dubai is here. 4623. If we return back here, 4623. Now, of course, my clicks here on the map may be a few kilometers offset, but you can see that Google uses a function for measuring distance that is pretty much the Haversine distance. Okay? So I think that concludes the lesson today, and if you have any questions.